So here is the most tricky part. In control part, we have taken some library functions that is pre-written to make it simple. So we will run the all cells from the top. Don't run any cell from particular middle of the script. So it has dependencies on previous cell, so it will throw error like I will run directly this in Python environment. So I think it will show error, so don't run the any cell in between. So it has shown error that joint variable is not defined because it is defined on its previous cell. So start running from top. It has dependencies, Python dependencies, which are Python libraries, which are SimPy and SciPy. So you have to install this both library by pip install to run this program. We have already installed, so no need to run again. So in math-utils we have defined some basic rotation and animation and unit vector calculation steps in functional form. So we can directly call it from here. In this vector norm, unit vector and angle between two vectors. So this function is will give the rotation matrix from the two vector. And for skew symmetric matrix also we have defined a function that from vector it will automatically generate the skew symmetric matrix. For rotation matrix from vector same like this. It is the in for planar vector, I think it will okay. And this plot 3D function will plot points and lines in a 3D manner for the given points. And this class H has the basic rotations definitions and DH parameters. So for the homogeneous transformation there is two options, from Euler angles or from DH matrix. So both definitions are defined. That is a rotation about z 90 degree means it's an input parameter. And similarly for DH, from DH alpha d aq and value we will provide, and it will automatically give us the rotation homogeneous transformation from DH parameter. So it is already run. It is shown the some preset outputs for the points given to it. Now that is our programming part, means calculation part. This is the simulation part, in which we have defined functions like connect to client and number of objects, and also defined joint variable initialization. So we will run this. If our CoppeliaSim is already running, yes, it is already running, so it will connect it automatically. For this we have already given the port number on which the API server is running. Successfully executed and added all 7 joint angles for our Coca LBR IVA 7. Number of objects already seen 80, and here it is shown the get joint angles for all the joints. Here is the all the initial joint angles which all are approximate 0. Say it is 10 to power minus 7 which is equal to 0. So now we can run the joint variable execute. Okay, it is rotating about some frame, so it is just simple rotation about joint 0. So this command will rotate our joint 0 from minus pi to pi. We can show this here. And the final one is to move robot to particular position from start position to end position. It has taken just position mode, so it is coming to QF positions, which is already defined in our imported libraries. So QF is this angles, so it will start from Q start and end to this position, so it get to Q final position. So that was the just setup part. It will be required for basic setup. Now in trajectory part, we have taken the few trajectories. In first trajectory was